This is our first application of factoring. We're going to practice solving equations with higher degree polynomials. So what does that mean? The degree of a polynomial is simply the highest exponent. So if the degree of the polynomial is 2, that means we have a quadratic equation. For example, x squared minus 2x equals 0 is a second degree polynomial because the degree is 2. The highest exponent is 2. Regardless of the degree of the polynomial, your first step is to put it into standard form. Descending order and equal to 0. Descending order means that the exponents are going down, and equal to 0 means put 0 on the other side. So that means you may have to move stuff around from one side of the equal sign to the other, or you may have to move stuff around on the same side of the equal sign. So in this case, the exponents are decreasing to 1. So this is in descending order and equal to 0. Therefore, we're in standard form. Once you're in standard form, factor completely. You'll have to choose which technique of factoring to use. Again, GCF always comes first. After you factor out a GCF, you have various tools that you can use, whether it's trinomials, difference to squares, or even factoring by grouping. The degree of the polynomial will help you determine which technique to use. Once you factor completely, set each factor that contains the variable equal to 0. And then solve these equations separately. So in this case, we're already in standard form, so we can begin factoring. GCF is x, leaving us with an x minus 2, still equal to 0. Since this is an equation, you can't lose your equal sign. Do not change an equation into an expression. So since this is factored completely, done with step 2. Let's move on to step 3. Set each factor which contains x equal to 0. 2 factors here. One here, one here. Set them both equal to 0 and solve separately. This one's already solved, x equals 0. Stick a box around it so you don't forget. Add 2 to both sides, so x equals 0 and x equals 2. The degree of the polynomial, in this case 2, will tell you the maximum amount of solutions you can have. Since the degree of this equation is 2, we may, not definitely, we may have 2 solutions. The maximum amount of solutions we could have is 2 because the highest exponent is 2. If the exponent were 3, we may have 3 solutions. That doesn't mean you will always have 3 solutions. Here's a second degree. That's pretty easy to factor. This is the difference 2 squares. Factor x plus 2, x minus 2. We have 2 factors. They both contain x. Set them both equal to 0. And solve separately. X equals negative 2 and x equals positive 2. All I did was subtract 2 from both sides of the equal sign here. I added 2 to both sides of the equal sign here. So these are somewhat elementary examples which you may have had access to in integrated algebra. A factoring by grouping example we can have is, let me just think one real quick, x to the third minus 2x squared plus 2x minus 4. Oh, not an equation yet. Now it's an equation. Equals 0. Otherwise it was an expression. We were factoring expressions before because there's no equal sign. So, alright, so now this we have to factor by grouping. Let's group these two. Let's group these two. Before we begin grouping, let's just take a look at the binomials that will be produced. We have a positive, negative, a positive, negative. That means we do not have to factor out a negative like we did the other day. So factor out an x out of the first term, leaving us with an x minus 2. So now we can see that's our common binomial factor. That's what we're looking for in the other term. We're looking for an x minus 2. Okay, so let's factor out a 2 plus 2 times x minus 2. And again, don't lose your equal sign. So we have a common factor of, oh, I messed up here, didn't I? That's x squared, common factor. Alright, so now we have a common binomial factor of x minus 2. If you still continue to write the let statement, that's fine. But that was simply to introduce the common binomial factor. You do not have to say let a equal x minus 2. But if it's easier for you, feel free to do it. You'll never get it wrong that way. So we have a common factor of x minus 2. And we're left with an x squared plus 2 equals 0. So now we have two factors. They're both factored completely. So let's set them both equal to 0 and solve separately. X equals 2. And in this case, this is not factorable. If we were to subtract 2 from both sides and take the square root of both sides, well, that's not allowed because you can't take the square root of a negative number. So that means there's no solution over here. So in this case, the degree of the polynomial was 3. The degree of the equation, I should say, is 3. So we could have had a maximum of 3 solutions, but in this case we'd only had 1. So another example where we have more solutions. So the signs of the polynomial, if we factor by grouping, we have positive, negative, which means we'll have a positive, negative binomial over here, negative, positive. So we'll have to factor out a negative here. Just thinking ahead there. We have a common factor of x squared, leaving us with 2x minus 3 for the first group. So we want a 2x minus 3 over here. Let's factor out a GCF of 4, so minus 4, because I want to change the signs to the second two. And 2x minus 3 in return. So now we have a common binomial factor of 2x minus 3. Let's factor it out. Again, if you want to include a let statement, that's fine with me. And we're left with an x squared minus 4. So now we have two factors. They both contain x, but we can't set them equal to 0 yet because we can still continue to factor x squared minus 4 with the difference 2 squares. 2x minus 3 times x plus 2 times x minus 2 equals 0. Now they're all factored completely. Now we can set them all equal to 0 separately and solve. Work on them individually. Add 3 to both sides. 2x equals 3 and divide by 2. X equals 3 over 2. But 3 and 2 don't divide cleanly. That's okay. Leave it as a fraction. Fractions are numbers too. Don't be racist. X equals negative 2. And x equals positive 2. So in this case we have 3 solutions. The degree of the equation was 3. That's telling you the maximum amount of solutions. That's not saying you will have 3 solutions. That's saying you may have 3 solutions. In this case we did. And if you want to check your work, you could plug in all 3 of your x values individually into the original equation and make sure you get 0 in return.